Okay, for the A part, second part, you can see, hence find the algebraic integration and the exact value of this area of R. Integration is given to you, that is 0 to pi by 4, 32 sine square of t cos of t dt, and you have to find its integration by applying the integration rule and plug in the values of limits, upper limit or lower limit. So it can be written as integration of 0 to pi by 4, 32 sine square of t cos of t dt. 32 is constant, so I can take 32 common, means outside of this integration 0 to pi by 4 as it is. Sine square t can be written as sine of t whole square cos of t dt. Why I convert sine square t into sine of t whole square? Because I want to apply the power rule of integration. I want to get rid of integration by parts. This expression can be solved by parts also, but that would be a lengthy process. So whenever shortcut is given to you, you can use that shortcut, then why you move towards a long process? So I convert this sine square t into sine of t whole square so that I can get rid of by parts and can apply power rule of integration. So this is 32 sine of t square cos of t. Now I can see derivative of sine t is cos t, that is present over here. So I can use power rule. Definitely I can use. It would be sine of t to the power 3 whole divided by 3, and the limits are 0 to pi by 4. So it can be written as 32 by 3 sine of t whole to the power 3, and limits are 0 to pi by 4. So I will plug back the limits over here. 32 by 3 sine of pi by 4 whole cube minus sine of 0 whole cube. That gives me 32 by 3 sine pi by 4. Sine pi by 4, you will consider the trigonometric table that shows the value of sine 30, sine 40, sine 60 and something. So sine pi by 4 means sine of 45. So its value will be square root of 2 by 2 by using a table. Whole to the power 3 minus sine 0 is always 0. So 0 to the power 3. So you can say 32 by 3 square root of 2 whole to the power 3 dividing by 2 raised to the power 3 would be 8. Minus 0 will remain as it is, just like 0. You can simplify with the table of 8. 8 times 4 is 32. So it would be 4 by 3 square root of 2 whole to the power 3. So it can be written as 4 by 3 square root of 2 whole to the power 3 can be written as 2 times square root of 2, because 2 raised to the power 1 by 2 and whole to the power 3 can be written as square root of 2 times by 2. That one. So that is the result that I have used over here, and calculate my answer as 4 times 2 would be 8. So it would be 8 by 3 square root of 2. That would be my final answer for this R. Right? So let's go back. B part suggests that show that all points satisfy y is equals to ax plus b. where a and b are constant to be found, and the equation of a curve that is y is equals to x over here, y is equals to f of x, and f of x is defined when x is minus 2 to 2, and a and b are constant to found in the part b. Okay, so in order to show that the equation y is equals to satisfy y is equals to square root of ax plus b, I have to consider the trigonometric equation first that are given to me at the start, that are x is equals to 2 cos of 2t and y is 4 sin of t. I will figure out my cos of 2t in the form of x by 2 and sine of t in a form of t by 4 or something like that, y by 4 you can say. So means I have to subject my equation in a form of sine t and cos t first. So when I did cos of 2t, which is equals to x by 2, and my y sine of t would be y by 4. Now the question arises, why I did this? I did this because I have to show my y is equals to square root of ax plus b. It means that it's necessary for me to use this trigonometric or a parametric equations in a form of cos and sine t, then I'm able to satisfy this relationship. Otherwise it's not possible for me. If you plug back the values of x and y over here, then definitely y lying here and x lying inside the square root, if you plug back the values, it is impossible for you to show that. So that's why I consider my equation in a form of cos 2t and sine of t first, right? So it would be cos of 2t, which is equals to x by 2, and y or sine of t is equals to y by 4. Then you have to consider the formula for complete angle formula for cos of 2t. Cos of 2t having a formula 1 minus 2 sine of t. That is a complete angle formula for cos of 2t. Now you know the value of cos of 2t, that is x by 2 here. So plug back, that is 1 minus 2 sine of t. Sine of t value is given to you, that is y by 4, you have calculated. So 2 times y by 4, right? So further you can see x by 2 is equals to 1 minus y by 4. So subject your equation in a form of x, you can see, or in a form of y. First of all, take the LCM. 4 minus y dividing by 4 is equals to x by 2. Let me check I'm right. X by 2, 1 by 2, sine square of t, here should be 2. So here should be 16. And here should be, after that, cutting 8. Yeah. Here should be 8, so it would be 8 minus y dividing by 8. So here should be y square also. So subject your equation as y square, that gives you 8 minus 4 times of x, right? So 8 minus 4 times of x, and you have to show your expression in a form of y is equals to ax plus b square root, but you have y square is equals to 8 minus 4x. So in order to get rid of this square, you will apply square root on both sides, and your y would be 8 minus 4 of x, right? So on this comparison, you can say your a is minus 4 and your b is 8. Why? Because you have a general form ax plus b. So on that comparison, your b is coming as 8 and your a is coming as minus 4. So that's why that will be your final answer. First of all, you did show this expression into a relevant form, and after that you figure out what are the possible values for this a and b.